Good morning, students. This is the third part, which is called as measurement of time and simple pendulum. Over here, we will be studying about time. It is basically focused on time only, and numericals will be coming only of this part. Means part A and part B. Even if the numerical is there in your textbook, but no numerical will be coming. Only numerical will be coming related to this part, that is measurement of time. Simple pendulum. Simple pendulum means what? A simple pendulum is a heavy point mass which is also known as a bob, which is suspended, which is moving from A to B, you can see, and it is suspended from a rigid support. Rigid means what? It will never change its shape. And string, we are considering that the string is massless, it is not having any mass. And inextensible means the string will never stretch, its length will remain constant. Over here some terms are there which we have already studied in 8th standard last year in chapter sound, but again these basic terms are quite important. First one is oscillation. Oscillation means what? One complete to and fro motion of a bob, of a pendulum. One complete to and fro motion of a bob. To and fro. To and fro means what? Take for example, over here bob is at point A. Bob will move from A to O to B, again B to O to A. So this to and fro means the bob, from whichever point it is starting, it should also come to that point only for one complete oscillation. It shouldn't happen that bob is moving from A to B and the oscillation is completed. No. Oscillation has only completed half of its oscillation at this situation. So for complete oscillation, it should again move to point A. Next one, period of oscillation. The time taken to complete one oscillation is period of oscillation. It is denoted by capital T and it is measured in seconds. Next one, frequency of oscillation. Frequency of oscillation is the number of oscillation made in 1 second. It is denoted by F and it is measured in hertz, or it is also measured in seconds minus 1. Amplitude. Amplitude means what? Maximum displacement of a bob from its mean position. Over here you will see this is a mean position. So maximum displacement means what? O to A or O to B. This is a amplitude. It is basically measured in meters because it is denoting the displacement of the bob. Effective length. Effective length means what? The distance from S to O is called as the effective length. It is the distance of the point of oscillation O from the point of suspension. This is a point from where it has been suspended. So S to O is called as effective length. Relation between F and T, or frequency and time period. Frequency and time period are having inverse relation. Means what? If frequency increases, time period decreases, or if time period increases, frequency decreases, vice versa. There are some factors on which time period of simple pendulum depends upon. Time period is directly proportional. This sign is denoting it is directly proportional. Even if it is looking like alpha, but it is directly proportional, it is denoting. Time period is directly proportional to square root of effective length. Effective length means what? This is the effective length. From year to year is called as effective length. So time period, whatever time the bob will be taking for completing its oscillation, is directly proportional to the square root of the effective length. Next one, the time period of oscillation is inversely proportional to the square root of the acceleration due to gravity. Like you have already studied, or you are hearing this term for the first time, that is acceleration due to gravity. It is denoted by small g. time period is inversely proportional. Why we are telling it is inversely proportional? Because it is coming in the denominator. Over here previously it was coming in the numerator. As it was coming in the numerator, so the name was directly proportional. But now it is coming in the denominator. So it is called as a inversely proportional. So time period is inversely proportional to root g. Means what is this term denoting? Whenever g will decrease, acceleration due to gravity will decrease, time period will increase. You might be knowing that this value of g, even if we are taking it as 9.8 meter per second square, we are taking average value of g. But this value of g goes on changing as we move from equator to poles or to the sea level. This value of g goes on changing. So this g's value, if it increases, time period will decrease. If time period increases, g will decrease. It is again vice versa. Next one. There is something relation of time period and length which we have already studied, that time period is directly proportional to root L. Okay. But there is some seasonal change also in the time period of the simple pendulum. The seasonal change means what? You might be knowing during summer what will happen to the length of the string? It will expand. During winter, what will happen to the length of the string? It will contract. So, due to which the clock goes faster. Clock will start ticking faster. Why it will start ticking faster? Because during winter, due to extreme cold temperature, the particles of the string will go on contracting. So naturally effective length of the string will shorten or it will reduce. Due to this reducing length, what will happen? Time period will also decrease. As both are directly proportional, length of the string is decreasing due to contraction during winter season. So naturally time period will also decrease. So what will happen? Pendulum will complete more oscillation. Pendulum will complete more oscillation in a given time period. I will repeat one more time. During winter, what will happen? It will become faster. Time period will become faster, or it will complete more oscillation. Why it is completing more oscillation? During winter, there will be contraction happening. So length of the string will decrease. As length of the string will decrease, what will happen? Pendulum, effective length of the pendulum will get shortened up. And due to this shortening of effective length, the time period will decrease. Next one. Clock goes slower in summer season. During summer, what happens? There is extreme heat. Due to extreme heat, what happens? The pendulum or the length of the string will expand. The length of the string will increase. As the length of the string will increase, we have already seen time period and length of the string are having direct relation. So as the length of the string will increase, the time period will also increase. So the pendulum will complete less oscillation in a given time period. So length of the string will increase, naturally time period will also increase. Okay, can you tell me the difference over here? Whose time period will be less and whose time period will be more? Let us first of all understand these two pictures. You can see one boy just sitting or swinging in this swing, and we can see this girl standing on this swing. What is the difference in the time period? Whose time period will be more or less? We will see now. While swinging, if we stand on the swing, this girl is standing. So what is happening? Its effective length is decreasing. Its effective length will decrease. So time period will also decrease. Effective length, take for example, this girl was sitting. So effective length was more. Now this girl is standing. So effective length from the suspension of the swing has decreased. As effective length has decreased, so time period will also decrease. See, this is because when we stand, the center of gravity rises. Center of gravity means what? Each and every body is having center of gravity. You can take a scale and scale you can balance at a single point, that is the center of gravity. So whenever a person is sitting, his center of gravity is below. Whenever the person is standing, his center of gravity rises. As his center of gravity rises, what happens? Its effective length of the swing decreases. As effective length decreases, so time period will also decrease. So it moves more faster. So you can see whenever a girl or any person standing and doing swing, we can see he swings or she swings quite faster as the person been setting in the swing. Next, factors affecting the time period of the simple pendulum. Time period, this is a generalized formula, that is T is equals to 2 pi, that is 3.14 root L upon G. We have generalized that L upon G. Over here we have already seen that L was having direct relation, G was having inverse relation. If we combine this two, what we will be getting? T is proportional to root Lg, but if we remove this proportionality sign, we will be getting 2 pi, that is a constant. Now, time period of oscillation does not depend on the mass and the material of the body suspended. So time period doesn't depend upon the mass, how heavy the mass is, how heavy the person is who is sitting on the swing. It will not be dependent. Time period of oscillation does not depend on extent of swinging on the either side, provided the swing is not too large. If the person is swinging to a greater extent, then the time period will not be affected. Next one, seconds pendulum. Seconds pendulum, as the name suggests, time required by the seconds pendulum to complete full oscillation is 2 seconds. It states as that it takes 1 second in moving from one extreme to other extreme. From one extreme to another extreme it will take 1 second, and from another extent to another, that extent only, it will take 1 second only. So total time is 2 seconds. Thus a pendulum with a time period of oscillation equal to 2 seconds is known as seconds pendulum. Thus a pendulum with a time period of oscillation. Time period of oscillation means what? Time period of seconds pendulum is what? 2 seconds is called seconds pendulum. Thank you.